So I'm Olivier Marlet, and I will, with Théo Roulet, present you our experience on using the SciDoc CRM to model archaeological datasets. The rise of the semantic web and the opening of research data in the open science dynamic are encouraging French archaeologists to apply FAIR principle to make their data sustainable, interoperable, and reusable. This is one of the main missions of the MASA consortium, to support archaeologists in this process by relying on the SciDoc CRM, a standard ontology massively shared by a large part of the cultural heritage actors at the international level. This paper's goal is to present how modeling with the SciDoc CRM can be adjusted according to the issues. The richness of this ontology allows indeed to set up models at different granularities in order to reach the according objectives. We propose to compare two experiences made in two research projects. The first one relies on a generic model for several archaeological datasets within the MASA consortium. And the second one requires a more specific model for excavation data and architectural data within the SESAM project, semantization and spatialization of multi-scale heritage artifacts. It's important to notice that both of these models are extracted from the SciDoc CRM and its extensions, without defining any new concept or property. This is a choice that we believe is required in order to be consistent with the best practices of the semantic web and the FAIR principles, and especially to ensure the data's interoperability. First, I will present the case of the generic model built for the semantic web platform, OpenArcheo. The MASA consortium has developed a SparkQL query platform for archaeological datasets named OpenArcheo. These datasets are quite heterogeneous: field recordings, epigraphic inventory, or catalog of artifacts. Each of these datasets has, of course, a different format and data structure. To pass these datasets into the OpenArcheo triple store, RDF triples became the obvious format. For the semantic structure, we naturally choose the ontology of SciDoc CRM, now widely shared in the cultural heritage domain. We therefore analyzed the most common concept in several datasets and made a selection from the SciDoc entities that best matches this concept. Of course, a few purely archaeological concepts did not find an entity that could represent them finely enough in the base CRM. Thus, we use the CRM Archeo, which provides us with the turnkey concept of the stratigraphic unit and also the CRM BA extension for archaeological buildings. It would have been irrelevant to fill in the gaps in the CRM with a new ontology specific to our project, especially for data interoperability. Therefore, we selected a few entities within these extensions when the CRM base concepts were not precise enough for our modeling needs. The two main entities are the site and the associated operation, a counter event, whether it is an excavation or a discovery. With SciDoc, a distinction is made between the site and as a physical element, that is the remains, and the place where it is located. The encounter event constitutes an important node in the model because this event can be placed under the responsibility of a researcher, himself part of an institution, and it can be dated. Above all, a counter event is the context for archaeological discovery. For the stratigraphic unit, we take advantage of the existence in the CRM Archeo extension of the perfectly adapted concept, stratigraphic volume unit, which can contain artifacts. The archaeologists group some stratigraphic unit according to spatial and functional criteria in order to identify pits, wall, burial, and so on. These concepts match with human-made feature, the traces left by human. The archaeologists can then group this feature into larger functional groups, necropolis, buildings, fortified enclosure. The structures match with the built work of the CRM-BA extension. Finally, the artifact is another essential entity in archaeology, especially insofar as it can help to interpret the context in which it was discovered and possibly to date it. The model therefore enables to identify the functions, but also the materials. This artifact is mapped using human-made objects. And for each of these entities, we can associate a title, a label, and above all, an URI, which enables to identify the resource without ambiguity on the web. These sustainable identifiers concern both the resource themselves and the instances linked to gazetteers. We use geonames for location, VIAF for individuals and or institutions, and Pactol's multilingual standardized thesaurus for thematic types. Each entity can be associated to documentation, and each document is typed photo, drawing, paper record, book, and can include metadata elements on the author and the date of creation of the resource. Each of these main entities can be associated with a datation, type pen, and this datation is detailed with a literal datation and dating boundaries for the beginning and the end in a necessary numeric version to be exploited by computer. All databases do not use all of these concepts depending on their scale. A dataset inventorying sites on a regional scale will of course not specify the stratigraphic unit or even the artifacts. The site and the operation are the common denominators of the large part of the datasets. Here are two examples. You can see that for the field recording database, we use every entities of the model, while for an artifact inventory, far fewer entities are involved. The OpenArcheo model is resolutely generic in order to facilitate federated research within various sources. Access to more specific information is reserved to the online dataset publishing these resources. However, on the same datasets, it's perfectly possible to consider a more detailed ontological modeling thanks to the SciDoc, but with another objective. This is what Theo will present us to know. Thank you.
Yeah, hello. Can you all see my screen?
Yes, that's okay, thank you.
Okay, so the work I will present to you now takes place in the context of a Sesame project. In the framework of this comprehensive interdisciplinary project regarding multi-scale build features, it specifically focuses on the means to confront and combine two different views of the same heritage items, the architect's view and the archaeologist's view. To do so, it associates the teams from three research labs, a team of specialists of architectural heritage from the MAP laboratory, a team of archaeologists from the CITERLAT laboratory, and a team from the LIFAT of computer scientists specialized on knowledge representation. So our test corpus is the still standing guest house building of Marmoutier Abbey, which is near Tours, with on one hand the excavation data stored in the LAT archaeological database, and on the other hand the architectural description of the elements of the building by the map. So our practical goal is to conceive an ontology to integrate and query both these datasets. And to formally describe the archaeologist's excavation data, we made the choice to rely only on the SciDoc CRM, because with all its extension, we thought it was a comprehensive enough framework to express all the archaeological knowledge we wanted to. So leaning on the work which was already done for the OpenArcheo model, we extended this model to represent finer grained concepts. First, the concept relative to the building archaeology, that is to say, representing vertical stratigraphy and the structuration of architectural elements. And second, the concept relative to the chronological analysis of our data, representing the chronofunctional grouping of the context. So the first step of our work was all about using the CRMBA, a SciDoc extension that completes the CRM Archeo and documents archaeological buildings. We exploited the CRMBA for its ability to link a stratigraphic unit, a context, to an architectural element, and also to represent how architectural elements can be associated together inside a building. So first, as you can see on the little schema in this corner, the CRMBA gave us a class to represent the vertical stratigraphic units and to formally distinguish them from the horizontal ones, which are also present in our corpus. Now, you must know that when grouped up, these stratigraphic building units constitute what the CRMBA calls a functional architectural element, represented here by the class B2 morphological building section. We use this B2 class to refer to any type of architectural element that can be found in a building, a window, an arch, a staircase, and even a wall. However, since those architectural elements can have different spatial scales, some of the smaller ones will be contained by the larger ones. On the illustration on the right, you can see that, in fact, the walls is containing all the other elements. So we choose to imbricate those in the model using the P46 property forms part of to indicate how some elements can be part of a larger functional whole. By doing so, we designed a very generic model for buildings archaeology, but a modular one, and that was all that we were aiming for. We only introduced the couple of archaeological concepts we needed, and the rest will be further expressed, detailed, by the architect's final description. The other invaluable piece of archaeological knowledge we had to represent is the chronological analysis of the horizontal and vertical stratigraphic unit. Because of the endurant and perdurant fundamental distinction between within the SIDOC, all the events affecting physical objects should be modeled as separate temporal entities, including the creation of these objects. So if we want to locate the stratigraphic unit in time and chronologically order them, we can do it through the events representing the beginning of our existence, and this is what you can see here. Now, the CRMBA and the CRM-RKO provide shortcuts, simpler ways to model chronological relationships between two individuals. However, they lack obvious solutions to assert more complex associations, and here that was what we were trying to do. Because representing an individual creation event for each stratigraphic unit enables us to model their gradual regroupment according to a chrono-functional logic, just like a Harris matrix is being progressively synthesized. So here you can see in blue on the right, the hierarchy of this ever spatially and chronologically larger group of creation of context, modeled as imbricated E5 events and then E4 periods. You can also see the PA property in blue, which is a shortcut to remind more easily to which architectural element these events apply to.
2 minutes left.
Yeah, okay, so I will just, to be very quick, we also wanted to represent the interpretative dimension of these things because these events are not factual past events, they're only the interpretation of the traces that remain. So we created a chain to represent the inductive reasoning, which is leading to the grouping of this context. This is what you can see in purple here, and it's made of SIDOC inf and SIDOC psi entities, and it's a very basic induction chain, but well, you will be able to see this more in detail if you're interested, and this could be more further developed for other purposes. And to conclude, we have seen that two examples of modeling with two distinct purposes in the field of archaeology: a generic model for a referencing service of various resources, a more detailed and extensive model with a specific research objective. In both cases, the use of a SIDOC CRM and its extensions proved to be very effective despite the complexity of the ontology. And for these projects, we benefited from the work carried out by the European Ariane Plus program to which we contribute. And concerning what I just showed you about Sesames, when we shared our attempt with the working party in charge of the conception of an application profile for excavation data, we realized that the representation of processes of archaeological analysis and interpretation is now a common goal for many data integration projects. Because the more we want to share complex knowledge, the more we need to document its context. So yeah, and I think all of you will talk a bit about this morning. So thank you very much for listening, and if you have any questions, we will gladly answer them.
Thank you very much. We have one question that was written in the chat. The question is if you can say anything more about how easy it is to work with the stratigraphic data for buildings from an archive.
How easy it is to work with the well, I'm not an archaeologist, but yeah, no, it was how easy is it to work? It's not easy at all, actually. And in our own modeling attempt, we met a lot of we had a lot of the structure was very complex, and this is why we choose a very generic model, as I showed you. And also in our archive database, there were a lot of concepts were not very strictly defined, and so using this CRMBA actually proved very effective to explicitate what we meant by architectural elements. And again, because there were many ambiguities, we stayed very generic. But no, it's not easy at all.
Thank you. Any more questions? So the answer is that May Keith is not surprised that it's not easy. If there's no question in the meantime, I have a small question about the gazetteers or the controlled vocabularies you were using. I think you mentioned geonames, and I was wondering if you're using any specialized archaeological vocabularies, like, for example, Pleiades or maybe the Getty AAT.
Yes, because it's simple to use geoname for the moment, and we can there's some gap in geoname, but we can add some elements if needed, and we think it's very simple and easy to use with web services. So we choose these gazetteers.
Thank you. Any further questions?
There is one more in the chat, Martina.
Yeah. Okay. How do you represent the interpretations in RDF?
Yeah, I very briefly showed it on the last schema. We made a chain of SciDoc entities, SciDoc inference and SciDoc science. It's the name of the two extensions which were designed to do so. So we made a chain of properties explaining, starting from the original data and going over, detailing the process to like the observation and then the belief, which resulted from this observation, and linking it to the final data produced out of that. So in our case, we started from a physical object, and we ended in an event which represented when it was created and to which larger event it could be linked.
Does it answer the question? Yeah. Okay. Thank you.
May I ask, did you use reification because you have to relate it to statements? You can't just relate it, the interpretation, it's always kind of related to a statement and not really to just one entity, to one instance.
Yes, but I think there is already a form of verification which is proposed by the CRM inf and CRM theorem inference in this case, because you have an entity which is a belief, and so you can represent the belief which resulted from something, and then to what it applies, saying that I believe this thing. So I think this is the form of verification.
Okay, thank you. Time is up, unfortunately. Please, Theo, stop screen sharing so that the next presenter can share the screen. The next we're going to hear is making practical use of linked open data by series binding. And yeah. Please go on.
I'm sorry. Right. Can you see the full slide there? I think I'm sharing the right screen now.
No, I'm still only seeing your video.
Okay. Sorry.
Maybe you have to click OK or something.
Yeah, it was just saying that I couldn't share it. I'll try again. Yeah, that should be working now. Yeah, that's better. Okay. Hello, I'm Kerry Binding from the University of South Wales. And you can see on our flag in Wales, we actually have a dragon. So if you're asking where are the dragons, hic sunt dracones. I'd like to talk today, much focus, including at previous CAA conferences, has been on the creation of linked open data and focusing on lower level technical details, including serialization standards, ontological models, etc. What I'd like to look at here is some of the practical usage of linked open data, in particular in the context of the Ariadne Plus project, and maybe also to demonstrate some of the associated benefits of actually using these compiled resources, sort of the use, the U in loud data. So I'd like to look at linked open data. What sort of forms can it take? Where might I find some of it? How can I use it? And what might be the benefits and maybe some of the pitfalls as well. Bearing in mind the target audience for this session, I won't sort of labor this point too much about what is linked open data. So I'm skipping many important details here. I've included some details and links though for those who are maybe a bit less au fait with what I'm talking about to be followed up later. And neither am I attempting to strictly or absolutely define linked open data, but some of the typical aspects characterizing it would include using HTTP URIs as resource identifiers to identify things, using some machine readable open standards for data representation and serialization, and the principle of linking between things and linking out to other things by referencing their URI identifiers. There's a general movement towards particularly scientific data being open by default. This increasing the openness and transparency, perhaps inviting and allowing the review of the data, cross-referencing it, and generally reusing it, and not just putting it into a silo to be archived forever. I've made a little distinction there between linked data and linked open data. You can produce linked data without it being necessarily open. There's some typical open licensing schemes, including Creative Commons there, Open Data Commons, Open Government License. But there are then, within those, there are conditional licenses allowing different degrees of openness. So you could have an attribution license where you ask for attribution of your work, or non-commercial licenses where the work can't be used in a commercial context. There's this principle of 5-star linked open data. And this, I think it's important to point out, this is not about quality. 5-star data can still be very unreliable and inaccurate, but it is open and people can make their own judgment then about the quality and the provenance. The 5-star scheme represents an incremental criteria towards linked open data. What sort of forms might it take? So you might have ontological models. You can see there's various different models, sort of overlapping in scope, many of them. They say the great thing about standards is there are so many to choose from. So there's not one model to rule them all here. You might have reference data, such as knowledge organization systems, the SORI, gazetteers, those sort of things. Or you might have data sets themselves in their own rights, knowledge bases. And this isn't a strictly mutually exclusive classification, as there are cases that cross boundaries here. And some of the items I've listed here fit into more than one of those boxes. And as I said, linked open data can take a form that's a combination of these. So Periodo and Numisma, for instance, they have a data model in their own rights, but they also expose reference resources, and they're a data set in their own right as well. You may have projects which have linked open data at their heart. It's part of the strategy, the design, or it might be a project that is a result of retro conversion of established or legacy data sets. The end result should be the same, but it may be more difficult to retrofit legacy data that's been produced originally from a different purpose and trying to cram that into a very strict semantic model. So you may run into some problems there. Some of the significant linked open data sources available, particularly reference resources here. The Getty Art and Architecture Thesaurus, which was mentioned earlier, they have a range of vocabularies there, the Thesaurus of Geographic Names, Union List of Artist Names. The first three there with a link through, they are linked open data now. The others that I've listed there aren't published via their main linked data search mechanism, but they are available via other API calls, and I think they're available for download as well. Wikidata there, I mentioned, that's a very large, comprehensive knowledge base, which is being incrementally improved by a community of interested people. And they contain many mappings out to other reference systems. So you go into Wikidata, you'll find there are already mappings to AAT and to other reference resources. I mentioned the heritage data thing. I mentioned that because University of South Wales were directly involved in the creation of heritage data, linked data infrastructure and resources. There were initially 5 vocabularies there. Now there are over 50. Heritage data vocabularies and services are utilized by Archaeology Data Service for improving the consistency of the subject metadata. We have Periodo there, and Ariadne Plus partners have contributed new collections to describe the spatiotemporal named periods referenced in their own data sets. And then we reference Periodo then from within Ariadne Plus. And Lexfo, that's a neat little resource to unambiguously refer to languages, types of script, and even individual characters. And there's references within there to the ISO 639 language codes as well. So the main question, how can we actually use this stuff? As I mentioned in the intro, much of the focus up to now has been on creation and publishing of linked open data. We want to discuss how we might make use of it in our own work. And one straightforward use is just simply referencing the existing URIs, the identifiers, to refer to concepts that will unambiguously convey to others what we mean when we refer to things like Iron Age or brooch or copper or something in our own data sets. There's no particular special infrastructure required to do this. All we need to do is reference these things and put those URIs in our own data sets. Although tools and services to perform lookups on these resources can make the whole task much easier. Now, there's an immediate benefit to this in improving the consistency of the data and also making links out to external resources. And that's one of the requirements of linked open data is to link to other things. Otherwise, it's just data, isn't it? You need to link it to other things to make it more useful. We can use linked open data for data enrichment. We can import selected data from one of these compiled quality resources, and we can attach to the data. We can validate and improve our own data by comparing it to these compiled resources. Some of the techniques that you might use include just simple referencing, as I described. You could do bulk downloads of the entire resource into your own system. The use of dedicated service APIs from remote linked data systems, or direct querying on if they make a Sparkle endpoint available, and web crawling. If you have URIs which can be dereferenced online, and you have a web crawler, you can go to that URI, bring back data about it, and dynamically build up a picture of the the information as you're going, a bit more of a complicated use of it. So I mentioned we'd look at some uses of linked open data in the context of the Ariadne Plus project. First of all, we have the AOCAT ontological model, which itself is extended from CDOC CRM. All the partner data in Ariadne Plus is converted to conform to the AOCAT model, which inherits from CRM entities and properties. We do enrichment from periodo resources. Often a data set will contain named periods, but then no further information about the context of those periods, what they actually meant. The Ariadne Plus data partners have produced specialized periodo collections describing the named periods used within their data sets. And we use those collections to enrich the data sets to include the URI of the named period from periodo and the date spans that they represent. We bring back in the dates that they meant, and it allows us to efficiently cross-search then all the aggregated records by date. Excuse me. And then Getty AAT mappings and Wikidata, we've used that. We've used the Getty AAT mappings. I'll get onto Wikidata. The vocabulary matching tool I show here, we've used this to facilitate creation of mappings from local source vocabularies to Getty AAT linked data URIs for interoperability purposes. It allows the user to decide a match by examining the scope and context of the target AAT concept. So we're not just matching on the term itself, we're examining where that term is in the hierarchy and what the scope note looks like. And this demonstrates a direct use of linked data resources in this particular tool, because we're using a remote SPARQL endpoint directly within the application. We don't hold the AAT within the vocabulary matching tool. We're using their remote SPARQL endpoint. We're searching for concepts there via the entry vocabulary of the terms. We're displaying some of the associated metadata. We're allowing navigation of the polyhierarchical structure of the thesaurus from within the tool. And that allows us to reference the linked data concept URI, the chosen one, and then that gets imported into the tool and used as part of the mapping. The resultant model data, once it gets into AOCAT format, we have local vocabularies that are mapped to AAT concepts using that vocabulary matching tool. The resultant model is one of native concepts mapped to derived concepts, what they call derived concepts, using these SCOS relationships, exact match and close match and narrow match and things. And then these are linked to the actual data resources, the records themselves. Also, the AAT mappings are used to enrich the aggregated records. So records are coming from different sources, all converted to this common ontological model, the AOCAT, but the data is nevertheless still not fully interoperable. And what you need to do is to align the subject indexing vocabulary that they've used somehow, because they're in different languages, they've used different local vocabularies. So this example I'm showing has some subject indexing in the Czech language. The vocabulary mappings result in mappings to AAT concepts. And so we've enriched the record with the AAT concepts that the original subject mappings were mapped to. And we can then search across the multilingual resources and find things that they have in common and surface new semantic links that are not immediately apparent or obvious, even in the records conforming to a common ontological model. They're still separate. This also shows near the bottom, there's a record enriched with periodo metadata. So the original named period there in Czech now has a date span associated with it. So we can treat it the same as all of the other periods and search right across them all.
1 minute left.
Thank you. This shows the Ariadne Plus search mechanism. We're typing into the search box to get suggestions of AAT concepts, and the results retrieved then originate from across different data partners. And we're using the AAT spine structure as a mediating mechanism, and the concept mappings allow us to cross-search multilingual resources without translating them, without the rigidity of using formal models. I mentioned Wikidata briefly. This is on the to-do list, work in progress. I won't say too much about it, but we're going to use it in the same way as we've used the local vocabulary mappings to use Wikidata's large multilingual entry vocabulary. And this is a further example of practical use of linked data, this time within a project called Matrix, AHRC funded project in collaboration with English Heritage, Historic England, sorry. And Keith May of Historic England, in fact, will be talking a lot more about this project after the copy break. So stay tuned for this. We're importing the Periodo data set here into the tool itself, and then using the imported periods as a pick list so that we can assign date spans to particular data items within the tool there. And we also do some validation then, comparing the dates in the Periodo to what we've assigned to individual finds and samples. So more to come from Keith there. Some of the benefits of linked data: publicly funded data should be publicly accessible. By being freely available, it's open to public review and feedback and contribution, and open licensing permits flexible reuse. And I'll just race ahead just to get inside the time. Potential problems: open publishing is a further step beyond just producing linked data. Most of the problems I've listed there are on the creator publisher side, and we can just leverage the efforts of others to improve our own outputs. Making practical use of linked open data has none of these downsides, apart from possibly the last one I've listed there, relying on external resources, because nothing is standing still or permanent. And there's a couple of links there to the projects and tools I've mentioned in the slides, plus some references to some related publications that you may be interested in. Okay, thank you very much.
Thank you, Kiri, for your presentation, which was a very nice introduction also to this session, I think. We have one question by Florian, who is asking if the vocabulary matching tool by Ariadne only makes uses of the SCOS relations like broader and related, or if there are also other custom semantic relations in use there.
It's only using the SCOS matching relationships at the moment. I mean, I'm open to ideas about different ways we could adapt it to different purposes, but for our purposes, we just needed those relationships.
Thanks. Any further questions? Okay, then thank you again very much for this really also nice introduction into linked open data. And we're continuing with the next talk, which is about linked open usable data for archaeology, including modeling of interpretations, by Brigitte Dantine and Gerald Hiebel. And we have a couple of minutes left, so you can so maybe I'm talking about this session again, which is about linked open data in archaeology, and which is part, as you can see here on the bottom, about the special interest group a special interest group in the CAA. And if you want to join or want to know more, you can follow the datadragon.link link and find more information, or you are always welcome to join in. Then please, Brigitte or Gerald.
Yeah, I will share my screen.
Are you even together there? That's nice.
Yes, so we don't need to switch. So can you see our screen?
Yes.
Yeah? Perfect. So yeah, welcome to our presentation about linked open usable data for archaeology, including modeling of interpretations. So, what? Okay, now. Yeah. The integrated projects were the following. First, prehistoric copper production in the Eastern Alps, Eastern and Central Alps. It's a joint project between Germany, Austria, and Switzerland. And this was followed by an Austrian project, the Open Research Data for Prehistoric Mining Archaeology, and where it was the aim to integrate all of this data collected in this first project. And now we have a project ongoing, information integration for prehistoric mining archaeology. And here is one of the goals, to use these data to make different analyses. And while each project has its own way of documenting their research and their output, and also each part of projects have their own way, all metadata were encoded with shared vocabularies and ontologies. And for this, first, the model behind all resources need to be general enough that all projects can be included, but also compact enough to allow the research on specific questions. And secondly, it also needs a shared vocabulary or thesaurus and ontology, which is usable but extended enough to fulfill all needs. And the integration of the data had three goals: to model the relations first between the research objects, like stratigraphical units or different findings. Then secondly, the activities like excavating or analyzing some findings or whatever. And third, the actors like archaeologists or labor or some other research institution were semantically modeled and separated from any interpretations. Yeah, I think the SciDoc CRM conceptual reference model I don't need to present to you. So just very shortly, the main focus of our presentation now will lay on CRM Archeo and CRM Inf and CRM Sci. Yeah, for the integration, a short vocabulary is needed. And here just a short screenshot of our thesaurus, where we integrated our thesaurus with the Daraya backbone thesaurus and the Getty AAT. Yeah, the Austrian data, they were collected according to the guidelines of the Federal Monument Office of Austria, and they're always the same structure, but they consists of a very wide variety of formats like text files, pictures, plans, always CAD, unfortunately, Excels, or also some other formats reaching from Illustrator to GIS things. And to in the first step, they need to be converted into archive standards according to the ADS, and this we automated with a Python script. And then, because Zenodo, we will upload all data to Zenodo, but Zenodo assigns only one single DOI per each data set, so the individual folders and files are not uniquely identifiable. And to make this possible, we created such a metadata file, also automatically within this Python script, in which each folder and each file receives a sequential number in addition to the Zenodo DOI, and is thus uniquely identifiable. You can see it here. And in addition, we have also uploaded the data sets to our Google Drive, so that whoever wants to access it does not have to download the data first from Zenodo, but is referred directly from the network to the corresponding Google Drive link, which is also generated automatically and is linked and connected to each folder and file. You can see it here. Yeah, for the modeling of excavation, which is mainly done with CRM Archeo, a very wide variety of information about the sites. Here, just some examples about the site, the sections opened there, the stratigraphical units with their descriptions and relationships to each other, or also the findings which were found in these different stratigraphical units, with informations, for example, about their material or about their usage were modeled. Yeah, I think I don't need to explain it very detailed. These informations were included in different tables which were related by the corresponding IDs with each other, and on this basis, the corresponding RDF network was generated. Here, just a visual representation of it is with just a small part of it with the information which contains it. Yeah, and just very shortly, because Florian Drie is one of the session owners, let's briefly mention the Sparkling Unicorn plugin for QGIS, really cool plugin he had developed. And this allows to directly query the RDF data within QGIS and to continue work through a Sparkle endpoint and to obtain a geometry layer provided with the corresponding attributes. So this makes it possible to really work with this data in QGIS and to continue working with it. But now I will pass to Gerald Hebel.
Great, thanks very much for this part of the presentation. And I'm going to speak about another thing we did in the Open Research Data pilot project. We have also analysis of copper axis, and what we wanted to do, we wanted to have a look how to represent a research paper within an RDF representation related to the data that we got from the project. So there's one paper, research paper about copper and Bronze axis from Western Austria, reflecting the usage of different copper types from the early Bronze Age to the early Iron Age. So we have different copper axes, in total it's about 170, I guess, and there had been analyses on their geochemical analysis, like you see here, a screenshot of a typical relation between lead and silver. And so what we have to do to represent the ideas presented and interpretations presented in this research paper. First, we want to see the locations of the axis, where were they found, and we have seen already in this session mappings of this type. We have physical objects, and it was found by an encounter event. First we have the types of the axis. So we have what kind of axis do we have here? We relate this to the cost concept, to the Hess type. And here you see different types of axes here in this picture already related to the time span, to the periods when they have been found, when they are usual for a specific time. Okay, and now we want to go to the find location. So the object was found by an encounter event. The encounter event has found at a specific place, or in other cases at some physical feature. And then the place we relate to its coordinates with the CRM geo property right now, but it can be done in future with the CRM property, which is implemented in CRM 700. And here we relate the geometry to latitude, longitude using WGS. So what can we get here, and it's also presented in the research paper, all the locations of these axes that were found and that were analyzed. And then we want, how do we model the periods when they were found, or the assigned periods? We are using here the inference making statement, because it is a kind of an inference, and there's an interpretation based on some knowledge. And we use a reification statement using attribute assignments. So we assigned the attribute to the physical object. We assigned a cost concept, which is the period, and the assigned property type is a CRM type or a cost concept. This cost concept, we have here some examples from the periods, and they are related to the thesaurus, which are not yet integrated with the period IO, but they will be matched to the period IO thesaurus. And so this is this upper part we just saw. We relate to this cost concept of period, and now we also want to see what was the reason for doing this interpretation, this inference. So it was motivated by either an observation, or it used as a premise. So this is a difference as a like you can relate to a belief, or you relate to an observation, or it is based on evidence of some document, or is documented in. So these are the strongness of the statement. You can change with these, using these ones of these properties. So what else was done? We had the geochemical analysis. So you have a Bronze Age X, a sample is taken here and it is analyzed for some specific elements. In this case, for example, iron, copper, silver, or lead, or some other elements. So here you see the elements which are routinely analyzed and rarely analyzed in this case. And how did we model this? We modeled it by measurement by sampling. We sampled from this physical object, our eggs, and a sample was removed. And then what was done was a data evaluation, and it was it relates to the sampling. So we have one sampling per eggs, but we have different data evaluations, because for each element that was evaluated in this sample measurement, we get one evaluation. You see it here, evaluation of cobalt, evaluation of iron, and for silver. And if you take, for example, this evaluation of silver to see the actual percentage of silver in this sample, we have this assigned dimension, percent of silver. It was the type silver is assigned, or the concept silver. And then we see how it has the value 0.34% of silver. And it was this, this is the XRF analysis. This is the measurement by sampling.
2 minutes left.
Excuse me? 2 minutes?
2 minutes left, yeah.
Thank you. And then the interesting thing is, after this evaluation, you can visualize it like that. Then there's an interpretation of different ore types, copper types. So we have arsenical copper, Fowler copper, or chalcopyrite copper. And we make another verification statement, and we assign this concept, these copper types. And what you get in the end is the maps which are within the publication, showing that in the early Bronze Age, we have a differentiation between Fowler copper in the more western part, and chalcopyrite copper in the eastern part. In the Middle Bronze Age, it's all about chalcopyrite copper usage. And in the end of late Bronze Age, we are having lots of diluted Fowler coppers. So thank you very much for Brigitte is taking the end.
Very short roadmap which of work we will do in the future, in the near future. So we will set up a public Sparkle endpoint, and as well as publish all data on Zenodo in parallel to it. Also in the near future, the data will be incorporated into the Ariadne project, with which a partnership has recently been established. And we also working on the setup of a whiskey, which is currently, but still in a pilot phase. But yeah, we will work on this 4 things. Yeah, thank you for your attendance.
Thank you very much. So are there any, there are questions. So there comes a question from, I think it's Keith May, it's not me, Keith, about, so he's thanking you for the interesting ideas and examples, and he wants, so he's asking if he wanted to find out what radiocarbon dated items you have in the project, should he search on the Ariadne portal or some other way, for example, through the Sparkle endpoint? So he's asking, where can he find the data you just presented?
Yeah, it will be published on Zenodo. I mean, I can send it to Keith anyway, but it will be published on Zenodo, but probably, and it will be integrated definitely in the Ariadne portal. So this will be the main distribution, I think, within the archaeological community. And we want also a Sparkle, install a Sparkle endpoint. We have it all. We have the triple store already in the university, but it is not open to the outside until now. This is our IT, our small IT problems.
Thank you. I have a question regarding the Sparkle endpoint. Which software or which system are you using for it?
We are using GraphDB.
GraphDB, okay. And for the, then I saw in your roadmap that you're thinking of using Whiskey. Is it still up to date? Is it still actively developed, or?
Yes, it is. They ported it to Drupal 9, and we are now in active contact with Mark Fichtner from the German National Museum to working jointly on a project, not only here and within this project, but trying to establish at the University of Innsbruck a Whiskey infrastructure for different projects, especially digital humanities.
Thank you. And there's, so Florian would like you to tell or repeat your, or talk about your experiences with the Sparkling Unicorn QGIS plugin.
Yeah, that's a really nice plugin, and it's really helpful. And yeah, it was quite easy to set up. There were some errors, but when you just use the system files and not the user interface, then it was no problem to set up the own Sparkling endpoint. And yeah, then you really can query all your data from the network. So you don't need to export it and then import it to QGIS or whatever. So I think it's also a missing link between the networks or the RDFs and GIS. So yeah, really cool plugin. Thank you very much for developing.
Thank you. Yeah.
I also know from own experience that you can post issues on GitHub and they are going to be responded on.
Yeah, sure.
Okay, is there any more questions from the audience? Okay, I can't see any more. Then I would say that we continue with the next presentation. Could you please stop sharing your screen? Thank you. So the next presentation is historic maps as a multifaceted cloud resource, and it's going to be presented by Junaid Abdul-Jabbar.
Yes, thank you. Let me share my screen.
Yeah, moment. Where is it here? Okay, go on.
Yes. Yes, you can see the screen. Hello, everyone. I am Junaid Abdul-Jabbar, working as a research assistant at the University of Cambridge. And I will be talking about historic maps as a multifaceted cloud resource. This is a work being done as part of mapping archaeological heritage in South Asia, or also known as the MASA project, which is generously funded by the Arcadia Foundation, by the Arcadia Fund. We are also joined here by Dr. Rebecca Roberts, who is the project coordinator for MASA project. We are in the early phases of the project and this work, so we will welcome any comments and suggestions there. So to look into what we are trying to do with the MASA project, it is a collaborative research project that is focused on the documentation of endangered archaeological and cultural heritage of the Indus River Basin that covers the areas of Pakistan and Northwest India. All of the information and the data that is being gathered as part of this project is being structured and stored within and managed within the open source online database using the ArcGIS platform. You can see the image of the search interface of the ArcGIS database with some records from the parts of Pakistan and Northwest India. So this project also includes a number of concurrent and collaborative development and training programs that will allow us to make this ArcGIS platform as a sustainable and a point of reference database for the local heritage professionals. Now to make and collect all of this archaeological data, we are referring to a number of data sources that start from the legacy data sources in form of the old publications. And then we have a series of ground surveys planned for ground truthing. And then we are referring to the satellite imageries and also to the historic maps that are the main subject of discussion here. So why historic maps? In the previous projects that have been done under the supervision of Dr. Cameron Petrie, who is also the principal investigator for AMASA project, the land, water, and settlement project and two range project, we have found these historic maps to be very useful, and they have an additional advantage in terms of the temporal coverage. That is one of the limitations for the satellite images and aerial photographs, such that these historic maps date way far behind than what is available from the satellite images. And given our project area and as a legacy of Britain's colonial past, there have been a series of Survey of India maps on a scale of 1 inch to 1 mile that document the thousands of archaeological features known as mounds. And these map series are available in majority from the years of 1905 to 1941, which are really helping us to capture these vast landscapes that predate the large scale agriculture and urban expansion. So in the image here, you can see some of the mound features that have been digitized using the historic maps in the orange point features. And then these can be related to the later sources like Corona satellite imagery from 1971 or a very recent Google satellite imagery to see how the landscape has changed or over the time. The paper copies of these maps are deposited with the UK legal deposit libraries, and in this phase we are in talks and collaborations with the British Library and the Cambridge University Library. So when we decide to work with these historical maps, we are faced with a number of challenges that really expose the multifaceted aspect of these maps. And for example, when we started working with these, we found that these are available as distributed collections of text, catalog, paper, and digital maps. You can see here a large map being scanned. So it makes this distributed collection makes it really challenging to identify the extent of overlaps between the collections in different repositories, and you have to work your way around this challenge one sheet at a time. And when you are when you are dealing with a large volume of historic maps, this can become really challenging. As you can see in the image here, this is the extent and volume of historic maps that we are dealing with in our project. Each tile can contain multiple editions of the historic maps. And we have also found that these map sheets are also existing as historical objects in their own right and can be used to generate rich metadata. For example, the information about the custodial history or the physical characteristics of the maps like vertical and horizontal folds, the information about individual surveyors and all sorts of these information. And we think that the value of these maps can be immensely increased if all these aspects are bring together and made part of a linked ecosystem where we have rich digital images, extensive metadata, the associated geospatial information that can aid it in a one interface geospatial discovery of these maps, and also to link these with the final driven product, which is basically the archaeological sites in this case. So to move in that direction, once these paper maps are scanned and the metadata is compiled, these are to be served by the individual libraries using the International Image Interoperability Framework, which has the goals to provide unprecedented level of uniform and rich access to these distributed image-based resources hosted around the world. And it does this by defining a common set of application programming interface. There are different APIs like preservation API and the other APIs that help us to support the interoperability between different repositories and greatly reduces the barriers to entry into this ecosystem, allowing this to be a allowed resource in terms of openness and usability. And there are also a number of shared technologies developed and available around the image servers and web clients to make use of these resources. So the libraries are already using IIII for a subset of the resources, and they have a vision to expand the adoption for these maps as well. And MASA team is assisting in every capacity where it could be possible by generating extensive metadata that can help these resources to be published as rich IIIF compliant resources for the individual libraries. And we are really focusing on geospatial findability aspect of these historic maps, and to amplify that geospatial findability and make it a fair data. We are working with the georeferencing of these maps, which is a really crucial step to make these scanned images useful for mapping and analysis purposes, and also results in generation of high accuracy spatial metadata. So we are using QGIS to use a well-distributed selection of ground control points spread across the map. You can see here there are folds in these maps, like these horizontal and vertical folds that results in the distortion, and less number of ground control points are not sufficient to achieve high accuracy. So you can not only go with individual with the four corners, but rather you have to select good distribution of GCPs across the maps. So once this information is available, it can be structured according to the linked data standards, and for that we are using the GeoJSON linked data within the web annotation data model. So the individual GeoJSON bodies would be related to the target IIIF resources that would be hosted by these libraries. And here you can see how this GeoJSON linked data object can be structured. So the IIIF map community is really working much to document all of these standards, and here you can see they are working on the documentation of the standard for the georeference annotation that would allow us to structure this image pixel coordinates and also the related ground coordinates. And this can be a list of these related points, so that we can better overlay our map onto any underlying satellite imagery or any underlying map and see the relations and the results of our georeferencing. So to assist with all of these, so to pace up the working of this model, we have a Python pipeline that will help us to generate the web annotations. So what it does is that once the maps are scanned as the IIIF resources and it can then take the high accuracy georeference maps and the grid spatial dataset, which are fed into a script based on the geospatial data abstraction library GDAL. It extracts the pixel and geographic coordinate information from these maps, and it then structures it according to the GeoJSON annotation body standards. Now, the libraries have unique identifiers for the maps in their system, which are being provided us with these initial scanned sheets, and these map identifiers remain uniform throughout the libraries. So we are using those unique map identifiers to generate the target URLs that would be fed into this part of the web annotation data model. And once all of this information is structured according to the W3C annotation requirement, this can be exported and saved, which leads us to the requirement of a user interface that is really capable of parsing and visualizing these annotations. There have been some demos available for this part in forms of the allmaps.org. This is the work being done by one of the co-chairs of IIIF Maps community group, Bird Spawn. And there is also another proof of concept known as the rhythm geolocator, which is being developed by one of the chairs of the IIIF Maps community group, Brian Herberger. So at this point, we really see a huge potential to tap into the ArcGIS platform to see how it deals with all of these annotations and IIIF images in a loud approach. Because in the recent releases of ArcGIS, ArcGIS 5.1 and 5.2, there has already been capabilities introduced to include the IIIF resources. And they have future plans to introduce this annotation capability of annotating the externally hosted images from within ArcGIS. So to look into more about what ArcGIS is, it is open source web-based geospatial information system for cultural heritage inventory and management. ArcGIS uses SciDoc CRM ontology. We can map our data to the CRM classes and properties using a special graph structure, also known as the resource models. And all of this is really promoting the interoperability of the data in the ArcGIS with other information systems, and lay the foundation of publishing the data as the linked open data. So in this diagram here, you can see different. So these are the individual heritage sites, and these are linked to each other. The user can tap onto one resource, and this graph keeps on increasing based on the relationships available within the database. So the historic maps would be linked as the information resources to these individual sites, so that the user can traverse through the links and go from one heritage resource to another, and eventually land onto these historic maps available as IIIF resources. For the usage of this database, would be public as we progress along with the project, and the user would be able to interact with the database and see the data according to the privileges available for them. And finally, we would like to acknowledge everyone who has been supporting our work so far. Thank you. I will now answer any questions if you have.
Thank you very much for this very nice overview of your project. Are there any questions from the audience? I can't see anyone written down. Is your system already live and ongoing?
Yes, so the system is not live at the moment. As I mentioned, we are almost around six months or so into the project period, and it is a collaborative project. We are doing collaboration with local stakeholders from Pakistan and Northwest India. So yeah, the initial the period of the project is targeted to 3 years, and hopefully it would be live within that period.
Okay, fingers crossed. There is a question by Keith about if the color of the color of the nodes does have any significance in the graphs you showed.
Yeah, so basically we are documenting the data in the different resource models. For example, we have the classification of our archaeological data into the archaeological landscapes and the individual heritage sites. And the ArcGIS, just when you see these resources when you see these resources linked in the ArcGIS visualization, it can show these in different colors and really highlight the resource model that is being targeted in the first instance. So in this example, the Taxila one is being loaded to see its related interface, so that's why it's highlighted. And And this is the heritage resource group resource model, and these are the individual heritage sites. But yeah, we are really working to refine these further.
Okay, thank you very much. Just giving a few seconds for any questions that still might be there. Otherwise, we're very, very good in time, and our coffee break will be longer than just 5 minutes. Thank you again for your presentation.
Thank you.
If you could stop sharing your screen, then I can go back to presenting. Okay. Okay. David is and Carsten Tolle are going to talk about linked open data, problems encountered and approaches to solving them in the numismatic domain. Please.
Okay, thank you very much. My name is Carsten Tolle, and I'm together here with David. So he's showing the slides and I'm talking, at least at the beginning, and then we're switching, so he's then having full control. We are mainly talking about problems, and we see here the main problems we are going to tackle in this talk. And as you see, these problems are probably not problems we're going to solve in this talk, and we are not aiming to solve them. And they are long-standing problems. We talked about uncertain data already in 2014 in Paris and other things in Tübingen, Atlanta. But let's jump into the first bullet point, David.
Yes, when I get my act together.
Now you stepped over one.
Yep.
Okay. So what do we mean with uncertainty? Of course, there are situations where you don't know the value. And in Numisma, where David and I, together with others like Ethan, who's also in this session involved, you want to say something is uncertain, you can add, for example, here in ochre to a mint that something is an uncertain value. That gives you the impression that something is not. If there's nothing entered, you don't know if it's uncertain or if it's just not tackled so far. But if you enter uncertain value, then you know that this is an uncertain value at the end. We also have in Numisma various issues like mints, for example. We don't know if they existed at all or where they existed, so we call them uncertain mints, and they're defined. But here the uncertainty is not modeled within the concept itself. It's basically the human reading saying, okay, it's an uncertain mint, and then we know what it is. What we mainly want to talk about, that's on the next slide, what we already presented in 2014, is we want to say, like there is this issuer connection between the coin and this issuer, and we are not sure about if it's correct or not. So we already had interpretations, or we heard about beliefs, and there are also various other names for uncertainty things mentioned below. But this is what we would like to tackle, and we thought about in that time. There are various solutions for it. For example, we already heard about reification. This is a standard thing on the left bottom side from RDF, which generates quite a lot of triples, to be honest. And if you do this for any case, you will run up in a very huge number of triples. Another possibility is to use extra properties that include this uncertainty, which is quite nice and solves a lot of problems, but also generates quite a huge number of properties, which is also not very good. And so we see on the upper right side, already also mentioned in the one talk before, this attribute assignment, which is very close to the reification, generates a lot of triples again. Sorry. And our most favorite approach is on the bottom left side, where we say, let's just generate a blank node in between, let's call it a scope node, and we can this way identify this is uncertain value that we attach at the end. The great benefit is, first of all, there are less triples, and second, we don't have this what is called a shortcut. because if you simply do a Sparkle query, give me the issuers of the coins, you would get the titles, and you don't even know that there is an uncertainty behind. So I personally think that the bottom left part is more safe. But of course, I think that's the problem. I mean, there are different people having different opinions, and everybody wants to do it his way. So next slide, please. So I listed basically up some resources like the uncertainty reasoning report from the W3C, dated back in 2008, then our stuff from 2014, but also in CyDocs-CM, this belief values is still an open issue. So it's not even closed yet, and also they see those different possibilities on solving it. So basically we have a problem because it's not clear how to do things. And this is, in our view, the conclusion in this bullet point, that we don't know how it's done, and basically smaller groups need to agree in order to exchange the data in a safe and secure way that they can talk to each other. Okay, so let's come to the next issue where we want to talk about data quality, and this is also mentioned already in one point where Ms. Cherry talked about the 5-star, where we say, okay, now is everything linked, but if the quality is there, we don't know. So in the stack for Semantic Web, the trust is at the very top level. If we want to prove it, then we need to really include into our model all the sophisticated inference techniques. I think we are not that far, we are still quite far from that. And the main problems is by really generating the data, entering the data, at least in our field where we are talking about with numismatists, where the data is entered by hand and we have the data quality issues. So our solution there is, next slide please, is basically at the moment that we don't use the inference things because it's not in our model itself, but we use Sparkle queries on the Nomisma ontology. So we can use those and reuse those Sparkle queries over different data sets, and the results then are stored in an Excel sheet that will also keep track over time which of those errors had been already encountered the last time we did the quality check. Next slide, please. And within one of our project from the DFG, we generated quite good results where we reduced the numbers of errors. And you see the inconsistent, which is on red. These are what we call the real errors, where it's really a semantic mismatch and something is wrong. The problem for the computer scientist, it's not easy to say what exactly was wrong in the beginning. So we always need to go back to the domain expert. They need to decide. And that's why the Excel sheets are for. They are distributed to the domain expert, and they can say, is it really an issue, or is there something different? We have missing data, and unfortunately, those missing data are quite common in archaeology. And then we have outliers. So have we solved the problem? No, with those queries, of course not. It's just, as everybody knows, data quality is basically starts at the very beginning when you enter data, and you're basically never able to finish data quality issues. So we are basically looking at some issues, but it's working. The more we define how the things are done, then the better it is. This data quality is also dependent on redundant data, and this we would like to compensate because redundant data is something, as from a data modeling point of view, you want to avoid. We are now in the phase that we want to extract from different sources additional information, like natural language processing from coin descriptions or from the images of the coins themselves, to try to figure out if there is what is on the coin, on the image itself. So we try to generate that. And next slide. There we have now in place a project called Clarinet, where we are working on those things, and another one will start in summer, together with Berlin, where we are working on that, and we're also trying to generate according tools that we can publish. And I think was my last slide, and I'm passing over to David.
Okay, then thank you, Carsten. This is now very much the non-technical, perhaps rather naive view from the domain expert that Carsten mentioned. We are the IT and domain. Duplicates across data sets. With Nomisma, we now have 54 different institutions providing data to web portals built around Nomisma, and these produce duplicates, and this is something we need to address. For example, if I take this example from online coinage of the Roman Empire, a coin of Septimius Severus, these are some of the coins being presented there, but it actually turns out that these two are the same coin. So how do we deal with this? Interestingly, both the two entries have different weights for the coins, which you can see. We also see this duplicates can be a very useful source for checking data. This particular coin comes from a hoard in Thüringen, which is represented in 3 different repositories, coin hoards of the Roman Empire, Kenome, and our AFE. And we're trying to institute links between these repositories in order to be able to note where coins are, or well, in this case, the find spot is represented across different repositories. So and then if we look at the level of coin, for example, the coin in the coin hoards of the Roman Empire project refers to the Kenome entry. It refers to our entry in AFE. And in the back end, we have a reference to the Kenome entry. So in theory, we can deal with this problem of duplicates. This has to be obviously implemented in online coins of the Roman Empire, and we will be addressing exactly this question in our next dump. But what we learned from this is architecture and the ability to do these things is one thing, but it's its application that has turned out to be very important. There's no use knowing that we have duplicates if the community is not discussing the matter, the community is not linking. This is the only way that we're going to be able to get around these duplicates. On the other hand, duplicates also highlight problems. For example, in this case, we discover that we have 2 repositories using the same geonames ID, but my database uses the wrong geonames. We didn't follow our guidelines. We put in the wrong geonames. We need to do this. Geodata is quite entertaining. For example, this coin in ochre from the Portable Antiquities scheme from Brigstock is its exact coordinates according to the Portable Antiquities scheme are these. This is the spot you see on the left. Portable Antiquities scheme, in order to not give the exact find spot, knock off figures from the end of the reference to give you this. But unfortunately, this reference, as you can see at the bottom, is translated into exact longitude and latitude, so that the vague find spot actually comes up as an exact find spot about 1 kilometer away. Ochre refers to the Wikidata entry for this find spot, which again is somewhere else. And if you go to use geonames, there are 2 other entries for geonames for this same find spot. This is something that Ethan Gruber is addressing in the data model for ochre, but it highlights the kind of problems that we are encountering when looking at duplicates across data. The next point we have is the level of granularity. We've gone quite a long way with the ontology and with our IDs and vocabulary in the Nomisma, but the question is, how far can we really afford to go before the whole thing just gets so granular it gets out of control? A fairly simple example is mints. The question for us was, is a mint a place or is it an institution? There's Byzantium, which later becomes Constantinople, which later becomes Istanbul. And this is a case of a mint which could perhaps be regarded as being politically sensitive. You don't want the same ID for all of these. And so we have 3 different IDs for mints in on the same location, saying which field of numismatics they are linked to. In the case of Byzantium, Islamic numismatics and Istanbul as the capital of the Ottoman Empire. But historically, numisma started off in the Roman world, and in the hope that Axel Posluszny is not listening, who will be upset about Cologne, we set up an ID for Cologne with the Latin name for it, and didn't really think about the problems of the fact that it's a Roman mint, it's then a Carolingian mint, and the archbishops of Cologne. And so at present, our ID for Cologne has a Latin name of the Roman town, but refers, as you can see, to the town through to the modern age, and has all fields of numismatics. Now we're going to have to divide up Cologne into separate mints, but that then raises the question of how I link those mints together in order to be able to put in a query for all mints, all coins produced in Cologne across the entire period of activity from Roman to the modern age. This means we have to look at the architecture. A rather specialized numismatic problem with granularity, and one that I'm working on, is the question of what is an imitation, a copy, and a counterfeit. The example of the tetradrachms of the owls of Athens, they were actually counterfeited at the time. Here, a plated coin, copper core with only a silver coating. This is a counterfeit, but as an international currency on a par with the dollar or the euro, it was copied by all sorts of people over several centuries. The question is, are these imitations, copies, counterfeits? What are that? And to what extent do we want to represent these different concepts in numisma, in our ontology? Then there are modern copies as well, which make it even more difficult. And even modern copies are complicated because we have replicas. You can buy them in the British Museum shop. You can get stung in the bazaar in Istanbul if you buy these, might get arrested for trying to export them at the airport. But also Bulgaria is famous for producing high quality fakes for the modern coin trade. These are implicitly designed to deceive collectors and dealers. So how do we want to reflect this into some sort of granularity in our ontology, in our modeling? At present, we only have one ID in numisma to represent some sort of copy, and that's an electrotype, a method used in the 19th century for copying ancient coins, above all. We are now introducing to numisma the concept of material reproduction, and I like the word surrogate being used here as a rather general word for what we're talking about. And we can then possibly look at a modeling approach to how to do this. We can say what we have is a numismatic object. It has the material plaster. It has the object type and material reproduction. And if we then introduce into our ontology reproduction of, we can link it to a URI of the original article which was being copied, because some collections have a coin and a copy of it as well, but they're different objects. The other alternative is we could then start to generate IDs of all of the individual kinds of copies, a plaster cast, a sulfur cast, an electrotype, a 3D print. Do we want to do that? But that basically leads us to two possibilities. The one is we have, well, Carsten used the word explosion. We're going to have kind of a modeling explosion, or we're going to have an ID explosion to cover all this. And for us now within numisma, it's a very simple practical question of how far down do we want to dig? How granular do we want everything to be? This brings us back to a kind of, particularly with the copies and imitations, which we don't really understand as a numismatist, brings us back to a level of vagueness and uncertainty, which is where Carsten started the paper. And I would like to close with thank you very much.
Thank you. We had one question, but it was answered during the talk.
No, I basically said to Keith that I will answer after David is finished, so I still need to answer that.
Good. Yeah, then please go on.
So Keith asked if I saw many attempts within archaeology data sets for coins to measure uncertainty as part of the data recording. Yes and no. It depends also mainly on which kind of coins the people were dealing with. So if you go in a coin cabinet, they have those very great coins with very low corrosion, etc. And there you don't have so many uncertainties, and they don't really, of course, in this situation, do not deal with that in that extent. David, for example, is coming from the area where he deals with coin finds, where you see those coins that are corroded, they're worn, and they're barely readable. And then, of course, you have to deal with uncertainty, and it's recorded. The question is to measure something. It's much more complicated if you really want to put percentage to it. We so far try to avoid that. So either we say it's certain or it's uncertain. But at least in our database, we have it basically for all attributes. And for some attributes, we also have a workaround to be more flexible, to maybe have some alternative settings and so forth. And sometimes you can also have those uncertainties within the value you enter. For example, he has sometimes values, sons of Constantine, for example, where you include a kind of uncertainty within the value. This son of Constantine is something we don't have, for example, as an ID in Nomisma, because it's a broader concept that kind of combines various others. So there are different things and different possibilities as well.
There's a follow-up question by Keith. You avoid percent. Why?
I avoid percentage because it highly depends on people. I mean, if I have an expert, he looks on the coin, he knows, and he's sure for 100%. If that's true or not, it's a different question. And then you have a student coming, looking at the coins. Of course, they're not that solid on ground and not so experienced, and then they have different numbers. And then you would need to have something on top that is comparing the numbers of students with numbers of experts, and then the expert changes his mind over the years. So I'm not sure if the percentage are really helpful.
Yeah, my problem with percentage is it kind of presents a degree of certainty. There's a certainty about the uncertainty, and going back to the topic of imitations, I can have two coin reports on the same set of coins, and the number of coins that are classified as imitations will vary possibly greatly between two people. Views on what is an imitation and what isn't an imitation vary massively. So it's a little difficult putting in percentages. It's not something I'm happy doing, to be quite honest.
Thank you. Okay, we got another questions, but we're already like in the coffee break. So if you want to have a break, so now it's like 8 minutes left until we start the next part of the session. So I would say, so one remark by Keith is, but all the data depends upon people, which goes like on a bit of philosophical level. And then
tell that to the IT people.
And then by Anna, we have the question how to attribute the different reports and modifications towards imitation, etc. Maybe one of you can answer that in written form, please, and then we can read the answer in the chat. And then for the others, I would say, please, let's do some break. And thank you very much for keeping in time with all your talks, and looking forward to the second part of the session.
Yeah, see you in now 7 minutes. And I think we have to quit this room and go to the other room. And yeah, hopefully it will be like this in the next part, because then we have 8 talks. And yeah, then we have a bigger break and then one more left. So see you in 6 minutes and have a coffee.